Hi everyone, and welcome to this 10th webinar of your nano degree. This is the latest one for Redux. We finished with Redux webinars, so it's in time for, this is the last week for the recommended time to finish your project about Would You Rather. Some of you have finished it, some of you are beginning it. But with this webinar, we finish everything related with Redux. So next week's will be based on React Native. I'm going to throw a test about a survey about if you want the webinars at another hour, about the content of the webinars. It's going to be 4 weeks about React Native, and until we finish having webinars, and we will be just having chats on one-on-one calls. So if you think that you need something about React Native in the next weeks, we can improve the webinars, the material. So if you have any suggestions about what you want to see, they are supposed to be about, first week will be about React Native development environment setup. So we will talk about how to set your environment to work with React Native. Next, the second webinar of React Native, we would be watching about Flexbox, the CSS framework or for styling used in React Native. And later, next week on webinar 3, navigation on React Native, and week 4, notifications in React Native. So these are the 4 webinars. So all the content you want to do with it, about it, advanced or not, please tell me. Okay, so this week we are talking about normalizing the shape of our state in Redux. Last week we had a webinar about asynchronicity, where we saw the Redux tank, and we had an example where we were building the shape of our states for thinking about a synchronous form where we want to show like information is being safe, is being loading, things like this. But I mentioned that we could be normalizing the shape of our state, but we wouldn't be doing that because that was the latest webinar to be done. So what's normalizing, or why normalizing appears? Okay, you will see even in your project, the ones you have done or you are finishing it, you will see that your state becomes big very soon. And usually the state is not just an object with key values object. It has nested values. It has a relational state. It becomes more or less quite complicated. And when we have this kind of structures, we have we have the risk of duplicating the data. So that's also happens in databases. So when you have duplicated data, for example, if you are updating a field, you have the risk of not updating it everywhere or properly, or deleting an item in one place, maybe you don't delete it in the other place. So because just because of the complexity, it has several problems with it. Okay. Also means that if we have a state, we have an actions and reducers, and reducers have to manage that state changes. So our logic would be more complex as we have a nested architecture. So we end having a big whole loops going here, copying, swallow copying, deep copying objects, because we have lots of duplicated data, nested data. And a very nice thing we could see, or you could see here, it's that imagine that if I am reading one object, if I have some all ancestors of that data, or structures that depend on that data, we have to be updating all of them. So we would be rebuilding all the components that are related with all those data. So we are like re-rendering data that is related, components that are related to that data, even that that data they are displaying is not related. Okay, it's not hasn't changed. So in this way, we only have like, okay, we only have the new objects reference to be rendered. So this is always nice if we only have a reference to an object and that object is changed. So all the references to that object don't change, because if you have, okay, in this view, I know that user ID is 2, and you know, I don't need to show that user information here. I just have the number. I know that you have that user ID. I am just displaying, you know, your invoices. I am not displaying your name, because I have only the number, the ID referenced. I just don't need to be updated, because that data isn't updated. But if we would have all the user instances copied in all the places where we reference the user, we would be having a place where we have invoices with the user object, even if we are not displaying that data, because Redux needs to update it, because we have to update all the places where user appears. That component should be also re-rendered. So imagine all the damage we are doing to our user interfaces, to our logic, and to our speed of it's not the name, but sorry, this is the speed, you know, the load time for our websites, so and apps. So think about that. So this everything comes from the original documents from redux.org. So for them, the basics or basis for normalizing states are 4 points. Always, every time you have your own one type of data, user, invoice, this kind of structure that means one type of data, we should put it in its own table. Okay, even in array or object, you know, it would have its own representation in the state. So they call it table. Sorry. Okay. Its data table should store the individual items in an object. Okay, so the items should be stored in an object, and the key of that object should be the ID of that item. Okay, and the object himself adds values. In this way, we can access this one ID. Okay, and anytime we reference those objects from other parts of the state, we should be referencing them by ID. I just said this when I was talking about the third problem of why we need to normalize state, because you know, if you only have IDs, the IDs don't change, so we only change the object that's all the IDs reference. Okay, and the last place is arrays of IDs should be used to indicate ordering. Something that some people don't know, even that advanced users of JavaScript, and and this is why React and Redux and these kind of things make you better at learning Redux is learning JavaScript. Sorry, is when you store an objects with key values and the keys are IDs, for example. They don't preserve the order. Okay, if you put one key 1 value 2 key value 3, maybe the object gets that doesn't have all that order. Maybe the next time you access that object has the first key is 3, the second key is 1, and the third key is 2. So we should be having an array indicating the order of those IDs, so we can preserve it, and so we have that ordering. And of course, it's easier for some other stuff, but that's the main problem for this kind of thing. So let's see a little example about the typical block, the sample from the original documentation. So we have this kind of state shape. We have a blog post. Here this is a blog post, and continues here the state. We have the second blog post, and we would be having others and others and others. So the blog post has its ID, the author, the body, and some comments related to that blog, and the same for the second post with other comments. So well, I see that maybe I should be like doing only this kind of state because this is just duplicated, but I usually see the errors just when I'm doing the real explanation on the webinar. When I am reviewing the presentation, I don't see the things of the life. So you see, it's just the normal state. We have as you see, the author is a user and the comments is another object. So in this place we are having like entities, or entities. We have, or data types as from the description. We have authors or users, comments, and posts. So this would be our three objects. Okay. So a normalized state would be okay. For example, in the original documents, they separate it. They do like, okay, these are the posts, the comments, and the users. They are the three entities separated in their own object. So this is like, okay, I have our own table. So later they have like this by ID. We don't tend having this splits by ID thing. Usually you will see this Y, and they have the all IDs. This is the array. Okay, this is the 4 point where the IDs are stored in for order. So we have posts, and we have 2 posts. So we have here the ID for those posts. So here you see, maybe the next time we access this object, it has first object, first property of that object is post 2 or post 1, so we can depend on that. I think that in newer versions of JavaScript they are doing this better, and I think they are keeping the order, but I didn't read it like from a original source. I just remember like reading about it, but I can't promise that it's a real information. So I will try to check it. See that inside its own table we have every object in its own table with the key, the ID, and the value, the own object. One moment, please. Sorry. Okay, so as you see, you have the key, the ID, and the object as the value. author, body, and comments. We have other things. Now, author is referenced. Here is the users. Both of them are all with the same shape, the by ID, where we have the objects, and the other IDs where we have like the array for the IDs for remember the ordering. So here the users. Now we have a user one with the username, with the name and name. Username is the ID. So here I think I forgot one arrow here, but you see that user one reference this object, and now comments references. Oh, comment 3 should be, this would be from here. I will change this, comment 1 reference. Okay, so you see now this is much better for this thing. Now in next picture we have the original here, so we can see it properly. I usually like to have all the information in the same view, so I work with two monitors in my IDE, Visual Studio Code. As you know, I usually split code into columns, so I have like the original, the gits versus diff or something like that. So you see, we changed this whole ID object that was, sorry, this post object. We said, okay, now this post object is, we have the ID, the author just references by its ID, the body is here, and the comments are also references by IDs. So now it's more easy to see this. We have the ordering and the comments. We do the same thing with comments, and we do the same thing with users. So now the information is related. Comments reference the comment here, and author references the user here. So this is the easy part. So what are the benefits after normalizing? As you are like, okay, we show that, okay, one problem was to be updating the objects in every place it appears. So if we have only an item defined in one place, we only have to update in that place, so we don't have to be doing multiple updates. Now our reducer logic is not as complex as before, and it's simpler. As you know, they are like these 2 points reference the 3 points why we should be normalizing. And the logic, it's for deleting, updating, it's or just retrieving an object. It's just easier because with the ID of that object, of that type, of that item, we just can look it up and without going too further to before, because the ID was inside the array, we should be like looping. So now we access the, in this example, the post by ID, and we pass as the position of the object, like the ID, and we have its value, the all complete object. So easy. So and this is and the fourth point is, okay, now we don't have to update every time we update the object, all the components. That's the test, the references, what I was telling the why we were changing. So we have these benefits. Okay, now if we reference, we have to for example, in the previous example, if we have a place where I'm showing like, okay, I'm showing here the post body, some body. Imagine we have the title also, and the author, and we are we retrieve the username to show the name of the user, so we show it, but we are not showing the comments. Maybe we are showing the number of comments, but we are not showing the comments in that view. If a user updates the comments number 2 in another view, this the view that, or the components that it's just a rendering this part of the content doesn't need to change, because that user is updating the comments, it's not deleting it. So we still have this comment here, this reference, but we just change it here. So we don't only update the views that are showing this comment, but not the views that are reference the posts. Okay, so that's what we gain. I think it's a very huge of impact on our speed and logic. Okay, so we need to know that a normalized state structure generally implies that more components are connected, and each component is responsible for looking up its own data. So independence. Okay, so as opposed to a few connected components looking up large amounts of data and passing all the data downwards. So we have like this kind of independence about the objects. Okay, of the components. Each component has its own data, and it's responsible of retrieving their data. These are advanced tips. Other tips that we should be using. The example with the by ID or IDs, it's not much used. Usually we should have every entity, the posts, the comments, and the users inside an object that it's called entities. So it's nice to find them, so everything is inside there, and the things outside entities are just referencer objects or entities. Okay, so another advanced tip, this would be, okay, we can begin to use our duplicate and gain complexity of our structure of our object, state object, sorry, because maybe it makes our things easier. For example, we can't divide, okay, if we have the comments entity, we can have like, okay, we can't duplicate it into current and work in progress. Current would be the usual normal contents, but if you go into a form where we're going to update that comments, we just make a copy of the current object and we put it in work in progress. So the views that needs to while the user is writing and changing that comment until he or she doesn't update that comment, the other views don't get changed because they reference the current. The only thing is changing is the work in progress reference to that object or copy of that object, sorry. And when we finish, we just update work in progress, copy it into current, and empty work in progress object. These kind of things are amazing. They become helpful if you depend on Redux for some things. Of course, it's when you have a complex data, because usually the work in progress form you should maybe doing its local state of React, but sometimes you want to see like even the changes that appear in while user updates a form, maybe you want to store them in a more more secure part of the application to recover it from user disconnecting or things like that. And the last one is just think if you haven't think about it, but I think it's obvious, these kind of entities represent a lot of examples related with relational databases. And so we can use everything we know about this kind of databases. For example, if we have a M2M relationship, we can't build that third table into our entity. So for example, if we have authors and books, and one author can have many books, and one book can be written by more than one author, we have this end-to-end relationship, so we can build the third table, that is the author book or the author by book, that has, related this author ID and book ID. So this makes our, as you see here, it lets us to build easier some queries like look up all the books by this author. So this kind of thing is, as always, engineering, designing systems, and thinking about data up front. And of course, don't get overwhelmed with thinking and thinking and thinking. But with little by little, with the time, you will be learning how to approach projects from the beginning, and better architectures to, make it easier for you. And you will be, okay, I need to do this because this query is always used in my application, so you will be doing your state. Okay, this is the second example and the last example about normalizing a state, because after this we just will go diving into a library. From the webinar 9, when we were talking about asynchronicity, I made this quick example about, okay, I usually selecting its country, and we want to ask the server about the city and populate the Dropbox for the select box for that city, and like doing the dynamic content and have it in Redux, because API calls are asynchronous, have them working. So let me check, because I am like crazy. Yeah, sorry. Just a quick explanation about the regional data. You remember we had the selected country, Spain, the countries, and the cities. We had the is fetching and did invalidate attributes to show if the is fetching if it's we are doing the API call, did invalidate if the API call answer responsive with an error, and the items just with an array of objects with the ID and everything. The ID of the countries would be the ISO code, but I think we didn't need it for here. So now this normalized, if we change it, we have now, okay, we have everything. See that now we are using the other tips. We create an object with entities, and inside the entities we put the countries and the cities. This is the continuation of this. So we are here, so we have our countries. Now countries need an ID, and every key of that object is the ID. Cities is the same as before, ID, the name, and the cities. So this is the part of the entities, and we have outside the entities we have countries and a cities object, where we have this is fetching and did invalidate information, and the items array. This is the all items, the $IDs items for ordering all these all IDs. So this is like, okay, I want to see the countries. Okay, is this fetching? Is did invalidate? What are the countries for this, or the number of countries? We have it. It's easy here. If we want to, the 3, we come here and we fetch it, and the cities is the same, and the selected country as before it was by name. It has it had the Spain ID. Now it references it by the ID of that country, and we know that in our shape of our state we have to go to the entities object, and inside of it then we have a key that is the name of that property, and the ID. So we would be fetching this object with ID, name, ISO code, and country code properties. Okay, so let me check if you have any questions related to this, because so let's give it 1 minute. Okay, so yep, this has been great, educational, very nice. We have to build our contents, our state shape, make changes on how to manage our state, but we have to remember that our state is beliefs in the client side, and this state comes from the server, usually from outside of our application, and we have to, maybe if we are building our own API, for a database, we can model it, like, okay, the response is like for how we use them, but we can't always do that because the API is used for by other services, and we have lots of APIs that are external; they don't depend on us. So sometimes we come to the place where, okay, I want the state being like, oh, inside the entities with IDs, with keys, with values related to objects, but the responses of our APIs are like, okay, here you have the objects with the data inside, without the proper the shape you wanted. So we can do it by hand, but this library Normalized came to the rescue, is the most used one. It was built originally by Dan Abramov, the creator of Redux, and in its third version was rebuilt from scratch by Paul. I don't remember the name, sorry, but the maintainer is another person. It's great. We are going to see it by in general, but normalize has three methods, three properties: the normalize, the normalize, and the schema. Normalize, function. Normalize inputs data, okay, by the schema definition we provide to it. So it has a first argument that it's the JSON data that needs normalization, usually the API response. Okay, this is the data we need, and the schema is the schema definition. This is where we say, okay, this is how we want you to normalize the input, and it returns us normalized JSON. Okay, so we pass it the data and how we want it to be normalized. Oh, I don't have the example here. So, I should be having an example. Okay, so sorry. I just put the examples for the schemas, but not for here. We will see it's at the end of the. And maybe for the PDF I will just change it. Normalize, it's the other way around. Okay. So just the normalize an input based on the schema provided entities from what you give it to him. So the input is just the normalized result. So for example, if you you can use normalize function, and the result of that normalized function, you put it here as the input. The schema is the same schema as before, and we will see what's a schema. And the entities. This is an error. So let's change here, because I have. Let me go to the documentation. Redux, normalized. Let me come here, normalized, Redux. Yeah, Paul Armstrong is the maintainer of this library. Normalized. Sorry. I will leave it here, as you see. Sorry for that. You see, this is the example. Let me put it bigger. See, we have the data. This is what, for example, the API should be responding in normalize. We create a schema. We will see how to do it that. And so the user, we create the schema and we pass it. Okay. So, and this is the normalized data that is written by the user, by the system. So, normalized is entities is an object keyed by entity schema names that may appear in the normalized output. So this is the entity schema names is an object. So this is we pass the users. This is a schema entity. So just for having here to be properly built. So okay. So now we saw how to normalize and denormalize. Okay. It's a quick view. At the end of the presentation, we have an example to see. I have opened the website for future references, but now the schema. The schema is what you see that we pass to our normalize function. The normalize, you won't be using it as much, maybe sometimes, but usually to dive in, you just need to usually do the schema.entity and the normalize function, and you just can begin to yarn add normalized, and you go into it. So these are the 5 types of schemas we have. And we have the first one, the array. It creates a schema to normalize an array of entities. It's just that, okay? Instead of an entity, we create an array of entities, and of course, we can pass an object, and instead of an array, the result would be an array of the object's value, okay? But just think about creates a schema to normalize an array of entities. So it has it needs two arguments. Let's put this in whole the screen, just hoping we don't need to reference it again. And we have the definition, and the definition is the schema that this array contains. Okay, just like that. So and let me here. And the schema attribute is the it's optional. And the attribute on its entity found that defines what schema to use when normalizing. So you see that we can go deeper and deeper to the what things are built. So here we have an example. See that we have normalized data. We call it with data and user list schema. The data is the definition. So we go here and we see data is just an array with the objects. So this is like user definition. The what has inside. We are defining the object. So if we use entity, it will I just get the, if you will see that the next part is the entity. We just create a schema for an entity. Okay, it will receive an object that it's user, and the content of that user would be what the API returns, and I would put it inside. But if we are saying in this entity, in this schema, in this user list schema, I'm going to say this is going to be an array. User list schema going to be an array of users schema. So here you see I should have put the entity first. I just followed the example, but entity is the first one we should see. So you see here I say it will have a users entity, and what's being brings from there, but we can in the user schema, because it's an array, we can say we can references what our data is going to be. So our definition, sorry, so so you know, oh sorry, I am just telling it badly. This is optional. I'm not doing the schema attribute. So we have the normalize. We have the data. This is the response from the entity, and the user list schema. This is the schema, and we go to the schema, and this is new schema array user schema. This is the definition of that array, and the definition is just another schema entity. We just don't go to the advanced part where we part the schema attribute. Okay, so just so you see, I think it's better to see first the entity, because the entity is the one used. So we'll put to entity first, and sorry about that, I just went so entity, it just creates the schema for that entity, and the value and the content would be just what is returned by our API. So the key is the it's the required part is the name for all entities of this type to be listed in the response. So you show that we have the users, we have the definition is the definition of the nested entities found within this entity, and we have the options. And the options is an object that has ID attributes, merge strategy, and process strategy. I didn't want it to focus in this very much because you have it in the documentation, but ID attribute is the attribute where unique IDs for each of this unique type can be found. Merge strategy, a strategy to use when merging two entities with the same ID value, defaults to merge the more recently found entity onto the previous, and process strategy, a strategy to use when processing the entity. Use this method to add extra data, defaults, and or completely change the entity before normalization is complete. Okay, so this is like advanced things. So this is the entity. So we have normalized data, and the tweet. Data is the response from the API, ID string, URL, and the user. Okay, so we're going to create the entity for the tweet for the user. So the user is going to, we have a schema entity. We just give it a name to read references. We just have the definition as a default object, and in the options we are setting the ID attribute to ID a string. Okay, so this is the unique IDs for each entity can be found. So we are saying, okay, this is the we are referencing the ID because it doesn't have the ID name. We just it's better to reference it. So it's nice in the options part to include these IDs. So now we can create our schema. What the schema really we want to use is that it's tweets. The tweets schema is name tweets, and the definition is user, because this is the definition is where every, as you see, is the nested entities we find in this entity. So we are going to define the tweets. That if it was just a simple entity would be ending like in here, like just tweets and gets things from the API. But hey, you are going to see something that references a user. I want to show you, we have a nested attribute inside a nested entity, so we have to put it in the definition in the second argument, and the third argument that has all these options. We have the ID attribute because tweets also have the ID string, as we have see here, and we want to how we want to do the merge strategy. If we receive two entities, we just want to create an object with everything from editing both entities, and also things that are the favorites from from the entity. I think that should be entity A. But and if the process, this is like things we want to do after, and we want to remove the URL field from the entity. So now we do the omit and we remove that URL. We don't want it in our normalized data. So that's the entity object and object define a plain object mapping that has values needed to be normalized into entities. Note this. This same behavior. I think that's outside. Let me come here. The same behavior can be defined with show and sync as well. I think that's not object. Too long. So it just has the definition, and we can see here. Okay, we just put the schema objects that we have response schema. It's a user that it's a new array schema that is defined by a user schema. Just that way, as you see, usually you will be using array, and union is for a schema that sits a union of multiple schemas. If you need polymorphic behavior and like crazy things. But we have also the definition, as always, that it defines how all the entities nested in our input array, and the schema attribute. The attribute on its entity found that defines what is schema per definition to use when normalizing, and has 3 parameters: the value, parent, and key. We don't go into it much because you will see in the example that we have what we want to do. The union has the definition and the schema attribute, that is the type. Okay, so this is what should be inside of it. So it's for advanced uses, just for you to know it. And values describes a map whose values follow the given schema. A singular schema that has the same as union definition and schema attribute, always the same. As you see, we have values schema, new schema values, the items, and this is the data. So these are all the parts you can have from normalized. If you go into array objects and entity, of course you have union and values, and we could go further to it, and it's in the docs, but I think that's a quick view of this is nice. So for example, we can do this example here where we see, okay, this is how you would be building the example from the blog post we were using. The original data for our I think that this is the response for a post. Okay, so imagine we have the post with ID 123. It has the author, that it's ID, username, name, has the body and the comments. As you see, it's a normal response of a API. It gives the complete objects. Maybe you could ask it for, okay, don't give me the objects, just the references, but you should be asking for the referenced objects, depending on how the API works. Remember, GraphQL, it's something nice because you can ask for what you need without changing how it's written. So if we join at Normalizr, from Normalizr, I have been writing the titles with D and it's with R, so yeah, sorry. So we define the user schema. Look at this. Post is new entity posts, and because it has a nested data that the author and the and the comments are nested data, we want to show it. Author is just another entity, and comments is an array of an entity. So we come here, we define the user, we just give it, okay, a schema entity that will be called users. You will see how it's referenced from the response. A comment, okay, it's going to be a comments, but it has a nested information inside. That is the author, that it's an user, define it above. And now we define the post, that is okay, is posts, and it has nested value, the author, the comments. We call the normalize function with original data and this post schema, and we would be seeing the response data, that is the normalize function, and we see that it builds it with entities array, and this is a quite nice information: entities, users, comments, posts, users by key with an ID, comments with the ID as a key, post with ID as a key, and the result that is okay. And this is the post reference is the 1, 2, 3. So we would be like, okay, we could be rebuilding the objects. And think about this now. If we needed some advanced, edition, we would be doing, this kind of extra parameters in our entity to say, okay, change things when it comes back. And now we have an object that we can change things about it after, before returning it for the action or the reducer. No? So we have like, okay, usually the action, no? Like, okay, it's better to have these kind of things in the action, so our reducers just take the information clear, no? The data clear. So this has been normalized function, normalized library, talking about how we should normalize the shape of our state. We could have done more examples about normalizing the state, but I think that using normalize function and seeing it, how it works, and okay, next time I want to do it in my project, or I can just put it there and try to just maybe in just one API call to use it, because it's going to make you work faster. So as always, if you have any question, I will be waiting if you have any question right now about what we've seen or things related about this week. Okay, so as always, I give you some resources. I don't reference the internal documents we use from the Normalizr, because you know what's the amazing documentation we have inside and how they talk about this, and so just want to reference, okay, the Redux docs where they talk about how you should normalize your state and what's the basis of this webinar. The link to the PDF for the latest webinar, when you can see how we built the cities, country, states, and the synchronicity things, and of course the Normalizr API data. This is it. We finished with Redux. So hope these webinars help you. And you enjoy listening to them as much as I enjoy them doing them. As always, you have me at the channel Slack. Every time you need something, every time you think you can learn something new or advanced data or something about an application, you are thinking about it, just write me. Remember, we have the one-on-one calls that you can use for whatever you prefer related to React, advanced, not advanced things that might help you with the project. Good luck for those who are submitting your other projects. Good luck for those who are beginning or